Hello, welcome to another interesting mathematics class. My name is AK Omoji. Today we'll be talking about logical reasoning. By the end of this class, you should be able to state the meaning of simple statements, identify simple statements, either to be true or false, and also show the negation of simple statements. For us to be successful in several professions, like in computing and in law, we need to be able to think logically. Now, since I've said we need to think logically, what then is logic? It is through logic that we establish whether a statement is correct or wrong. Also, logic can be referred to as propositional calculus. Recall that while defining logic, I said that logic is used to establish whether a statement is right or wrong. So now, what is a statement? A statement is any sentence that can either be true or false at a particular time. That means a statement can be true or false, but cannot be both at the same time. You should also note that all statements are sentences, but not all sentences are statements. Since we've agreed that not all sentences are statements, but all statements are sentences, let's see the difference between them. Let's look at some statements. The school buses are always late. This can either be true or false. Now look at the corresponding sentence that is not a statement. Welcome to Simforest E-Campus. Notice this is just an exclamation. It is not a statement because there's no need thinking if it's true or false. The next statement here is mathematics is a part of all aspects of life. This can also be true or it can be false. So it's a statement. Now, the corresponding sentence on the board is, how can I start understanding mathematics? This is just a question. It's neither true nor false. Let's look at the third statement. You cannot learn if you do not concentrate. This can be true or false. The sentence corresponding to this is now, when you get to school, make sure you concentrate so that you can learn. This is just an advice. It's neither true nor false. Okay, let's look at this simple mathematical equation. 1 plus 1 is equal to 3. This can be true. It can be false, right? Well, I know you know it's false. So it's a statement because it can either be true or false. A sentence corresponding to this is the sum of 1 and 1 equal to 3? This is actually a question, so it's not a statement. The last statement we can see on our board now is 3 minus 2 plus 1 is equal to 2. This can also be true or false. Therefore, it's a mathematical statement. Well, if I say, please simplify all equations, it is not a statement. Having seen the differences between statements and non-statements, let's now see places that they are applied in real life. Statements are used in real life in everyday conversations, in court hearings and arguments, in debates and arguments, in research questions, in scientific hypotheses and theorems, and other logical reasoning scenarios like in budgeting, negotiation, marketing, and so on. But we use logical reasoning to test if these statements are either true or false. It is important to note that a statement can either be simple or compound. But in this class, we'll be discussing the simple statement. And what is a simple statement? A simple statement is a statement that has one subject and one predicate. For example, Abuja is the capital of Nigeria. This is a simple statement. Simple statements are the building blocks of logic, and they are also referred to as propositions. In logic, we represent these statements with small or lowercase letters like P, R, S, etc. Let's look at a few examples. Number 1, 2 is a prime number. Let's represent this statement with P. Number 2, 2 plus 3 is equal to 6. Let's represent this with Q. Number 3. 1 is greater than minus 2. Let's represent this statement with R. Number 4. The solar system has 9 planets. Let's represent this statement with S. The truth value of these statements above are: the first one, please note that prime numbers are numbers that can be divided by themselves and 1 only. Therefore, 2 is a prime number because you can only divide 2 by 2 or by 1 without a remainder. Therefore, our first statement is true. The truth value will be T, indicating that it's true. In the second statement, 2 plus 3 is equal to 5 and not 6. So, 2 plus 3 is equal to 6 is false. Therefore, the truth value of Q will be false. Number 3. 1 is greater than minus 2. This statement is true. Therefore, the truth value of R is T, meaning it is true. For the fourth statement, actually there are no longer 9 planets as we used to know. Therefore, that statement is false. However, note that the statement was true from 1930 to about 2006. So that means a statement can be true at some certain time and false at a later time. But for now, that statement is false. Therefore, the truth value is false. Earlier on, we agreed that a statement can either be true or false. So, when do we say a statement is true? A statement is true when it is real or a fact. So, it's a property of being real or fact. However, a statement is not true when it is not real or when it is not a fact. Also, the truth value of a statement can either be given as T or F, depending on whether it's true or false. Now that we know how the truthness or falsity of a statement is established, let us look at negation. What is actually negation? Negation is simply the denial of a simple statement. How do I mean? To get a negation, we simply put a not before that statement. For instance, 1 plus 1 is not equal to 3. This not here indicates negation. Also, Lagos is not the capital of Nigeria. This not here also indicates negation. In logic, negation is shown by a tilde symbol. This symbol here is referred to as tilde. Example, tilde P means not P or negation P, and tilde Q means not Q or negation Q. If you look at the table on the right hand side, you see that if a statement is true, the negation of that statement will be false. Whereas, if a statement is false, the negation of that statement will be true. Let's see examples of where negation is applied. Our first statement, 2 plus 2 is equal to 6. Let's represent that with P. The negation of this statement will be tilde P, which means negation P is 2 plus 4 is not equal to 6. The next statement there is 3 is a factor of 10. Let's represent this statement with Q. The negation of this statement will be tilde Q, which is the same thing as not Q, would be 3 is not a factor of 10. The third statement is Nigeria is in Africa. We represent this statement with R. The negation for this statement will be not R, which means Nigeria is not in Africa. The fourth statement is 5 is a prime number. Let's represent this statement with X. The negation will be tilde X or not X, and it will mean 5 is not a prime number. The last statement is 3 is greater than 5. Let's represent that statement with Z. That will also mean in the negation form not Z or negation Z, and that will now be stated as 3 is not greater than 5. Please note this. 3 is not greater than 5 could be 3 is less than or equal to 5. But in logic, we are going to first leave it as 3 not greater than 5. Now let's talk about the truth table. The truth table is used in logic to establish if a statement is true or false. If it is true, it will be denoted as T, and if it is false, it will be denoted as F. In the truth table, statements are connected using what we call the connectives. And the basic connectives are the conjunction, also referred to as logical and. The symbol is a caret sign. The next is disjunction, also known as logical or, and the symbol is like a small v. The next is implication, also referred to as conditional. The symbol is an arrow pointing towards the right hand side. The next one is called by implication or by conditional. The symbol is an arrow pointing in two directions, actually a bidirectional arrow. The last is called negation, also referred to as logical not, and the symbol is a tilde sign. Now let's see an example of how statements are presented in a truth table and show their negations also. The first statement is 2 plus 4 is equal to 6. The next statement is 3 is a factor of 10. And the last is Nigeria is in Africa. If you look at the table down here, you see that the way we generated this was, for the first statement, which is P, we ask ourselves, is 2 plus 4 equal to 6? Well, the answer is true. So we will indicate here true for a P. Next, we ask ourselves, is 3 a factor of 10? What's your answer? Well, 3 is not a factor of 10, so it will be false. Finally, is Nigeria in Africa? The answer is true because Nigeria is in Africa. To get the negations, all you need to do now is to get the opposite of that initial value. For instance, we first of all say that 2 plus 4 is equal to 6, right? And the value was true. Now, the negation of true is simply what? False. So, 2 plus 4 is not equal to 6 is false. Now you repeat the same thing for the other statements. Having solved that example, we've come to the end of this class. But before we go, let's take a summary of all that we've done so far. First, we learned that a statement is a sentence or expression that is either true or false. Next, we learned that logic is used to test whether a statement is true or false. Also, we learned that simple statements are the building blocks of logic and they are also called propositions. Furthermore, we learned that all statements are sentences, but not all sentences are statements. Next, we learned that statements and logic is used in courts, discussions, arguments, decision-making, research, and so on. Next, we learned that the same statement can be true in some occasions and false in others, but cannot be both true and false at the same time. Finally, we learned that the truthness of a statement is denoted by T, while the falsity of a statement is denoted by F. Now it's test time. Question 1. P states that 3 is greater than 5. What is the negation of this simple statement? Option A, negation P states that 3 is less than 5. Option B, negation P states that 3 is not greater than 5. Option C, negation P states that 3 is not less than 5. Option D, negation P states that 3 is not greater than or equal to 5. The correct answer is B. That is because whenever you negate a statement, you're simply saying not that statement, right? So if you're saying P, 3 is greater than 5, then negation P will now be 3 is not greater than 5. Question 2. Which of these is not a logical statement? Option A. There are 4 states of matter. Option B. You always go to school early. Option C. The sun rises in the east. Option D. Welcome to my home. The correct option is option D. Welcome to my home. This can neither be true nor false. Thank you for your time. I'm sure you now know about statements. Till we meet in our next class. For now, bye-bye.